So this is the third part of the course, which includes combination circuits. A combination circuit basically has a series and it has a parallel. It could have more than one parallel, it could have more than one series, but this is basically gives you an idea on a series and a parallel combination. So the first step we want to do is identify the parallel and series branches. And that's what I did. So we know that from our course in parallel that we have a common rail that helps us identify our parallel branches. So we just give that a circle and we put that as parallel. This will be called RP or REQ once we find the resistance of the parallel branch. The second part we want to find is R series. So this is the R series. The reason we're going to take and break down a parallel branch into a series, because we know a series circuit is much easier to solve than it is for a parallel branch. Once we know that the REP or REQ, we actually want to do is redraw the circuit so it includes that in there. So we're going to take this part of the circuit right here, find the REP, redraw the circuit, and put that in as the load. That's what we call the equivalence of this parallel circuit. Once we have that, now we have a standard series circuit, and we can do is solve for anything we want: R total, I total, VR1, VRP. We really want to have VRP. VRP is going to be the voltage at this point right here, which is the voltage over here. So that's going to be our branch voltages. Once we have all that, we can actually find IR2 and IR3. Once we know IR2 and IR3, we can add these two together and we can find I total. We can solve for I. We can actually see if I total is the same. If it is, then we know our math is done correctly. So that's what we're going to do now. So if I take the circuit and I labeled it like I did before, I want to find RP. RP is the parallel resistance. That's 200 times 200 over 400. So it gives me 100 ohms. And remember that if two resistors are the same in a parallel branch, then we just could divide by 2 is another way of doing it. So that's RP. So now we found RP, or we could call that REQ, whatever you want to call it. We're going to take that and put it into our series circuit. So we're going to take the circuit, replace this with REP. That's what we did down here. Now we have R1 and RP. Now what we could do is solve for R total. So R total is equal to R1 plus RP is equal to 200 ohms. Now that we have the 200 ohms right there, we can find I total. I total is equal to the V total over the R total. So that's just 10 over 200. That's 50 mils. From there, I can find VR1 and VRP. So VR1 is 5 volts. Basically, that's IR relationship. 50 times 100 is 5, and VRP is I total times RP is 50 mils times 100 is 5 volts. So when we have that, I can actually go back and put the VRP back in, and that's now going to be 5 volts. So VR2 and VR3 is 5 volts. That's how I got that down there. Now what I want to do is find IR2 and IR3. Well, that's just taking the 5 volts and the 200 and getting 25 mils. So you got 25 milliamps on this branch, and you have 25 milliamps on this branch right here. So at this point right here, as they're starting to come back in, so we got current going this way and we have current going this way, we know that this should add up to I total. So if we actually take 25 and 25, so if I take, using Kirchhoff's current law, so if I take I total minus the sum of IR2 plus IR3, I should get approximately 0. So if I look at 25 plus 25 is 50, 50 is 0. So it's 0 amps. So we do have all of our answers actually correspond to what we should have. So I could even move on to something else, and I could actually do is find, let's say we want to find on this circuit, let's say I want to find on this circuit, let's say I want to find PRP. So I want to find PRP. Well, I just take this circuit here, the series circuit, and I could do is find the power through this resistor. So PRP is equal to I squared R. I could do I squared R, that would be RP. If I do that, that makes it easy for me. Here I could do it because I have 50 mils, 50 milliamps, and times it by, and my RP is 100. 100 ohms. So if I actually take 50 times 100 ohms, I get RP. So that's going to actually give me about 25 milliwatts of power through PRP. And again, I could find all my power. So this gives you a basic idea of how a combination circuit works. If you have any questions, please feel free to outreach to me. Thank you.